Hi there, and welcome to this lesson on Pure Mathematics 1. And in this lesson, we'll be considering translating graphs. Now, translations are a type of transformation. Transformation is the more general idea, and it includes things like rotations, reflections, enlargements. Understanding transformations, the reason for it is it allows you to sketch the graph of a complex function just by making a small adjustment to the graph of a far simpler function that you already know how to sketch. In this lesson, we're only thinking about translations. And a translation, it either moves an object in the y direction, upwards or downwards, or it moves an object in the x direction, left or right. Or it could do both, up and down and left or right. What a translation never does is change the shape in any way. So it doesn't change the way the shape looks to you, it doesn't change the size of it or the orientation of it. First of all, we'll look at translations in the y direction. Now, if you have y equals f of x plus a, that's saying you've got some function and you're going to add a to it. So you're adding a to the y values, and that moves the graph in the y direction upwards by a units. It's what you would expect to happen. It's a translation of the graph of f of x by the vector 0, a. So, for example, if you had f of x plus 3, you've got exactly the same thing as the graph of f of x. It's just going to move upwards by 3 units. It's a translation of f of x by the vector 0, 3. And f of x minus 3 would do the opposite thing. It would move the graph of f of x downwards by 3 units. The translation by the vector 0, minus 3. Now, translations in the x direction, you need to be a little bit more careful with because they're not intuitive in the way that translations in the y direction are. If you have y equals f of x plus a, here we're adding a to the x values. So the a is in the brackets and we're adding it to the x value. Now, you would expect that to move the graph to the right because you're adding on a, but it doesn't. It does the opposite thing. It moves the graph of f of x left, backwards by a units. It's a translation of the graph by the vector minus a, 0. So that's important. When you adjust the y value, if you add a, you get plus a in the vector. But when you adjust the x value, if you have plus a here, then you have minus a as the vector. It moves in the opposite direction from what you would expect. So, for example, if you had f of x plus 3, it actually moves the graph of f of x backwards, left by 3 units. It's a translation of the graph by the vector minus 3, 0, not plus 3. And f of x minus 3, that would increase the values. So it would move the graph of f of x to the right by 3 units. It's a translation of the graph by the vector plus 3, 0. So it's important to remember that. It's very easy to get confused on it. Translations in the y direction, what you would expect to happen, does happen. But a translation in the x direction, it is the opposite from what you would intuitively expect to happen. Okay, I'll let you have a go at this example yourself. So we'll start off just by sketching y equals x squared. And then the idea is that we adjust the graph of y equals x squared to account for these different possibilities. I'll let you have a go yourself first, pause the video, and come back to me again when you're ready. Okay, let's have a look at these. So first of all, y equals x squared. Well, that's the graph of y equals x squared. Y equals x squared plus 3 will be the same as the graph of y equals x squared. We're adding on 3 to the whole function. So we're adding on 3 to the y values. So the graph is going to move vertically upwards by 3 units. Exactly the same shape, but it'll move up by 3 units. So the crossing point, instead of being at the origin, will be at plus 3. Y equals x squared minus 4. Again, we're adjusting the y values here. We're taking away 4 from the whole function. So the whole function will move down by 4 units. Same shape, but the crossing point will have moved down from 0 to minus 4. Now we're asked to find the intersection points with the axes. So these 2 points here, they can be hard to find on some questions. On this question, it's not too tricky. They're on the x-axis, which is the line y equals 0. So we just say what happens if y equals 0. Well, if y is 0, then x squared minus 4 is 0. X squared equals 4. X equals plus or minus 2. So this crossing point here will be at minus 2. And this crossing point here will be at plus 2. That's question 3 done. Question 4, y equals x plus 3 all squared. Now we're not adding on 3 to the whole function this time. We're adding on 3 to the x values. So this is going to be a translation in the x direction. And the opposite thing from what you expect happens. So when you add on 3 to the x values, what actually happens is that the function moves left by 3 units. So it'll move back here, and the touching point on the x-axis will move back from 0 to move back 3 units to minus 3. There's a crossing point here on the y-axis. Those are always easier to find. You just say what happens if x is equal to 0. Well, if x is 0, we'll just have 3 squared, and 3 squared is 9. So this crossing point up here will be at 9. Question 5, y equals x minus 2 squared. Well, again, we're adjusting the x values. So it's going to be a translation in the x direction. Does the opposite from what you'd expect. So we've got minus 2 as the adjustment we've made. The function is going to move right by 2 units. We'll be adding on 2. So same as y equals x squared, but it'll just move right by 2 units. And the crossing point moves from 0 to 2 on the x-axis. And again, to find this crossing point on the y-axis, we just say what happens if x equals 0. If x is 0, then we've just got minus 2 squared. Minus 2 times minus 2 is plus 4. So that intersection point there will be at 4. Okay, example 2, exactly the same idea, but they use functional language for this question. So we've got 2 functions. F of x is a cubic, x plus 3 times x minus 1 times x minus 4. And g of x is also a cubic, just x cubed. And you're asked to sketch the following functions, noting again where each curve intersects with the axes. I'll let you have a go yourself first. Pause the video, come back to me when you're ready. Okay, let's have a look at these. So question 1 just asked us to sketch f of x. Well, f of x is this cubic, x plus 3 times x minus 1 times x minus 4. These are always far easier to do when they're factorized, as this one is. We want to know the crossing points on the x-axis, which are where y equals 0. So if y equals 0 or f of x equals 0, that means x plus 3 times x minus 1 times x minus 4 equals 0. One of the brackets has to equal 0. So either x will equal minus 3 in the first bracket, plus 1 in the second bracket, or plus 4 in the third bracket. It's right way up cubic, so it'll start bottom left, finish top right, and cross at those 3 points. So it must look something like that. Starting here, crossing at minus 3, 1, and 4. And the crossing point on the y-axis will be where x equals 0. And if x equals 0, in these brackets, we just have 3 times minus 1 times minus 4, which gives us plus 12. So the crossing point on the y-axis will be at plus 12. Question 2 asks us to do the same thing, but where we add on 2 to the x values. So f of x plus 2. Now that's a translation in the x direction, because it's the x values that we're adjusting. And it's going to be a translation minus 2. Does the opposite of what you have here. So the whole thing is going to move to the left by 2 units. So you'll get something like that. Minus 3 will move back to minus 5. The crossing point at 1 moves back to minus 1. And the crossing point at 4 moves back to 2. Now, finding the intersection point with the y-axis could be tricky. The easiest way to do it is rewrite this function. Now, our new function says it's the same as the previous one, but add on 2 wherever you have x. So here where we have x, we'll have x, add 2, add 3. That'll give us x plus 5. And here we'll have x, add 2, take away 1, which will give us x plus 1. And here we'll have x add 2, take away 4. So wherever there's x in the original equation, you replace it by x plus 2. And that'll give us the function f of x plus 2, which will be x plus 5 times x plus 1 times x minus 2, which is consistent with what you would expect, because the plus 5 gives us the crossing point at minus 5, the plus 1 gives us the crossing point at minus 1, and the minus 2 gives us the crossing point at plus 2. Then it's easy to find the intersection point on the y-axis. We just say what happens if x equals 0. Well, if x is 0, we'll have 5 times 1 times minus 2. That'll give us y equals minus 10. So this crossing point down here will be at minus 10. Question 3 asked us to sketch g of x, which is just x cubed. So it'll look something like that, with a point of inflection at the origin. Part 4 asks us to sketch g of x minus 8. We're taking away 8 from the whole function. So we're taking away 8 from the y values. And that means that the whole graph is just going to move down by 8 units. So it'll be exactly the same as this shape, just move down by 8. So that the intersection point there on the y-axis is at minus 8. To find the intersection point on the x-axis, well, if y equals 0, x cubed minus 8 is the new function that we have. We've taken away 8 from x cubed. So g of x take away 8 is x cubed minus 8. And we need to solve when that equals 0, which means x cubed equals 8, which means that x will equal plus 2. So that intersection point there on the x-axis will be at plus 2. Okay, last example. This time we'll look at what happens with a reciprocal curve. With a reciprocal curve, you have asymptotes. So that's the only thing that'll feel slightly different with this question. And we're given f of x equals 1 divided by x. We have to sketch the following curves again. And this time they ask for 2 things. They ask us to state the equations of the asymptotes. So the equations of the straight lines that define the asymptotes. And again, we're asked to note where the curves intersect the x and y axes. Have a go, pause the video, come back to me when you're ready. Okay, let's have a look. So first of all, we'll just sketch f of x, which is just 1 divided by x. It's the standard reciprocal curve, and will look something like that. Now, we're asked to state the equations of the asymptotes. The asymptotes are the lines which the curve approaches but never touches. And in this case, that's the x and the y axes. So the curves get closer and closer to the x-axis, they get closer and closer to the y-axis, but never touch or cross them. And you could just say that the asymptotes of the x and the y-axis, or you could say they're the lines y equals 0 for the x-axis and x equals 0 for the y-axis. Part 2 asks us to add 1 to the whole function. So the whole function is increasing by 1, the y values are increasing by 1. So the whole function is going to move up by 1 unit. And you would get something like that. Now the asymptote that's the y-axis, that just stays the same. It remains as an asymptote. But the x-axis asymptote has moved up by 1 unit. So that green dotted line at y equals 1, that becomes the asymptote for f of x plus 1. And that would be the equation for it, f of x equals 1 over x plus 1. So the asymptotes will be the line y equals 1, which is the green dotted line, and the y-axis, which is the line x equals 0. We still need to find this crossing point on the x-axis. Well, if f of x plus 1 equals 0, that means what happens if y equals 0? That's the function. F of x plus 1 is 1 over x plus 1, which has to equal 0. That means 1 over x equals minus 1, and that gives us the solution x is equal to minus 1. So this crossing point here on the x-axis will be at x equals minus 1. Part 3 asks us to sketch f of x minus 2. Here we're adjusting the x values. And we've taken away 2 from the x values. the opposite thing happens to the curve. So the curve actually moves upwards, moves to the right by 2 units. So it'll be the same as 1 over x, but it'll move right by 2. So the y-axis asymptote, that has moved right and become the line x equals 2. That is an asymptote. The x-axis is still an asymptote. That one hasn't changed at all. So the 2 asymptotes now are y equals 0, the x-axis, and this line here, which is the line x equals 2. We need to find this crossing point here on the y-axis. Well, what is f of x minus 2? It means wherever you have x in the original function, you have to replace it with x minus 2. Now, we only have x in one place. It's just 1 divided by x. But instead of writing x, we write x minus 2. So f of x minus 2 is equal to 1 divided by x minus 2. You just replace the x value by whatever it says here, which in this case is x minus 2. Now, we need to know what happens when x is 0, because we're trying to find the crossing point on the y-axis. And if x equals 0, then this becomes 1 divided by minus 2, or minus a half. So this crossing point here on the y-axis will be where y equals minus a half. Okay, that gets us to the end of this lesson. If you've got the textbook, then turn to page 69 and have a go at exercise 4D. Thank you very much for listening, and cheerio.